I am Dimitrina. I'm teaching chemistry in a high school, and this is my nephew Martin, who is 12 years old.
Hello everybody.
We are starting a series today where science will be this powerful tool which can help us to understand different phenomena. But as you can see, I'm not in my usual chemistry lab. I am in my kitchen at home, and you will be surprised how many chemical processes are going on while we are preparing our favorite dishes. Today we are going to talk about something which everybody, I think, likes: chocolate. Marty, are you chocoholic?
I am a very big fan of chocolate.
Oh,
yes.
And which is your favorite chocolate?
Milk chocolate is my favorite type.
Okay. But we are going to perform a very simple experiment which can help us to discover something very interesting about chocolate. So what is unique about the chocolate? Chocolate contains more than 300 chemicals. Some of them are known as stimulants, like the famous caffeine. Others are antioxidants. But one of the reasons that makes special and unique the chocolate is the temperature at which it melts, just below the body temperature. It melts in your mouth. But actually, do all chocolates melt at the same temperature? This is what we are going to discover with Marty with a simple experiment. You can see here, these are all stuff from my kitchen. We are going to dip, we have 3 bowls here and 3 different chocolates: white, milk and dark. The favorite chocolate of Marty was milk chocolate. Okay, so Marty is going to dip these chocolates and record the seconds, the time, which is needed to melt all of them. So our hypothesis is that all the chocolates will melt at the same temperature. Is this so?
I don't think so, because some chocolates melt faster, some slower. It matters on the chocolate.
Oh, but we have to perform an experiment to prove this.
Yes.
Okay, so Marty made a temperature which is around 50 degrees. Marty, can you measure the temperature now?
Of course I can.
I think we need to make the water with a higher temperature, or is this okay?
It's
45.
It's 46 degrees.
46 degrees. Okay, so Marty, the pieces of chocolates have to be the same size.
Yes.
Marty, can you dip now these chocolates?
Of course I can.
Okay. And we are going to start.
Of course.
The time. So we are going to stir from time to time the chocolate. Marty has prepared a table where he will record the time for melting the chocolate.
Yes.
Oh, I see the white chocolate already melting.
It is nearly melted.
Nearly melted. Okay, so Marty, you have to see the time, no?
Yes.
When it melts entirely.
Yes.
What about the other chocolates? You can stand up, you can stand up. Usually the scientists do the experiments, no?
Okay, the
Like
white
this.
chocolate is completely melted.
Melted, okay. Can you write down 54 seconds?
Of course.
54 seconds under the white. 54.
54 seconds.
Okay.
Let's see the other ones. Let's see the dark chocolate.
The dark chocolate. How is the dark chocolate looking like at this moment?
Only the bottom has melted for now.
Only the bottom. And what about the milk?
The milk chocolate, also the bottom, but probably soon it will go to the top.
Okay.
It looks like the dark chocolate is winning for now.
So it's resisting, no? The dark chocolate.
Yes.
Okay.
It wants to be the winner, I guess. The milk chocolate is nearly completely melted. What time are we?
2 minutes now. I will help you with the dark so that
Yes.
they are at the same conditions. It is very important when you perform an experiment,
Yes.
all the conditions to be the same. So this means same pieces of chocolate, the same temperature during the experiment,
Yes.
the same stirring.
Milk chocolate is melted.
Okay, 2:28, 2 minutes 28.
2:28 minutes.
And the dark chocolate 2:40.
2:40.
2:40. We are going to transform after that minutes in seconds and make a graph.
After our experiment, we made a graph to see which one took the longest time and which one took the shortest to compare. As you saw, the white chocolate melted the fastest. That's why it has the shortest column. Then it was the milk chocolate. And finally, it was the dark chocolate, which took the longest time to melt.
Thank you, Marty. This was great. This is the graph which Marty built. And of course, he deserves a piece of his favorite milk chocolate.
Thank you very much.
This can never be eaten after the experiment. Unfortunately, we have to throw it away. Now that we have produced with Marty some data, we can try to find an explanation why different chocolates have different melting points. The development of chocolate as we know it now has rich cultural history. Over the years, scientists and manufacturers have refined their process of production of chocolate from cocoa beans, utilizing their increasing knowledge of chocolate chemistry. Everything starts with cocoa tree, or Theobroma cacao, meaning literally food of the gods. The tree grows in a tropical area, and it is believed that it was first cultivated on the coast of Mexico around 500 BC. Then it was transported to Europe in Spain, and the first chocolate was produced in 1847 in Bristol. What happens when beans reach the manufacturer? They are roasted and crushed lightly to obtain the cocoa nib inside. Half of the weight of the cocoa nib is due to cocoa butter. The other half is due to cocoa solids. Cocoa butter is an important ingredient in chocolate. It is composed primarily of fat molecules. Here I have a part of this fat molecule. You can imagine 3 long carbon chains together, but for our purposes this will be enough to explain how these molecules and their arrangement will determine some of the properties of the chocolate and actually also the melting point. The fatty molecules can be arranged in different ways, and it turned out that depending on the way of arrangement of these molecules, the cocoa butter can exist in 6 different arrangements or so-called crystalline forms. There is a scientific term for this, which is called polymorphism, from poly meaning many and morphism different structures. different crystalline structures. Now, I said that there are 6 different crystalline structures which differ in the way these molecules are arranged. As I don't have many molecules, and you have just to imagine many molecules, fat molecules arranged, I will use these sticks so that I illustrate the different polymorphic forms from 1 to 6. The arrangements of fatty molecules will determine some of the qualities of the chocolate. Form 1 is considered the most disordered crystalline form. As you can see here, I have all these sticks in a very disordered manner. So this form is characterized with the lowest melting point. Form 2, you can guess, the molecules are slightly more ordered than form 1. And going up with the number of the forms, reaching form 6, we actually have, with time and with the temperature, ordering of the molecules, packing very well, which at the same time will bring the melting point of the chocolate and the form respectively getting higher. The finest and actually the most preferred form is form 5, which has a melting point, as we said before, which is just below the body temperature. It is the form, or it is the chocolate, which is exactly melting in our mouth. So this means that these forms from 1 to 6 differ in their stability and melting point. The more packed the molecules are, the higher the melting point. In the process of production of chocolate, controlling the temperature is essential so that the percentage of form 5 is assured. But this is actually not the answer, the final answer of our question, why different chocolates have different melting points. The process which is controlling and assuring the highest presence of form 5 is called tempering. Things though in the production of the chocolate are not so simple as I am telling them. The cocoa butter composed of cocoa fat molecules, you remember these molecules, is not the only ingredient in the chocolate. Very often there are different percentages of milk fat molecules and other ingredients. Now we are very close to answer the question, why different melting points? And probably you can guess. If we have high percentage of form 5 and high percentage of cocoa butter, which are present in form 5, the melting point will be high and you will have this pleasant mouthfeel melting of the chocolate in your mouth. And the chocolate will be glossy and will have a good snap. If we increase the percentage of milk fat, which is the second ingredient in the chocolate, this will slowly decrease the melting point and you might end up with a chocolate which can melt in your hand. So the difference in melting point is not actually a different structure of the molecules. It is how the fat molecules are arranged and the percentage between the cocoa butter and milk fats. I think everybody can recognize a good chocolate. It has a smooth texture, it is glossy and has a good snap. Unfortunately, a chocolate can deteriorate. You might have an experience of opening a chocolate and seeing a white spot on the surface of this chocolate. This means that the precious form 5 has been transformed in form 6. This usually happens in a range of 1 to 2 years. Unfortunately, this deteriorates the quality of the chocolates, and nobody wants to eat such chocolate. It's just not appealing to eat it. But remember, this preserves the structure. You have the same molecules, but these molecules are arranged in a different way. So, in this video, we learned many things about the chocolate. We found What determines the melting point of different chocolates? It turned out that depending on the percentage of cocoa butter and milk fat, the melting point differs. We also stressed out the importance of form 5. The higher the percentage of form 5, the higher the melting point, and also it assures that the chocolate will melt in our mouth. We also learned about the so-called polymorphism. This means the existence of molecules in different crystalline structures. Thank you for watching.